Hey, CHEM 2P20 students, Dr. Zalesko and colleagues. Ian Gordon here, Science Librarian in the Gibson Library. Just to give you a brief presentation on skills you'll need to know to complete this assignment, but more importantly, things you need to know to learn about important Brock chemistry faculty and resources that will help you not only now, but as you move through your career at Brock University. Coming from home here with my dog Bella, this will take a few minutes, but hopefully it'll be enjoyable as well. Here's the Brock Gibson Library homepage, a number of resources. Note our library hours, and note library hours are extended as you move towards exam period as well. But click on research guides, and it'll give you the faculties and departmental pages for a number of subjects, including maybe one that you're taking if you're not a chem major. But click on the chemistry, and it brings up this particular page. On this page, it has a number of things on the left-hand side, how to find articles, books, definitions, like encyclopedias, dictionaries, handbooks, theses, chemicals. We'll explore some of these things, including the services and resources. But on the bottom, you'll see the 4 lines for the resources that are associated with this particular assignment. They're probably in Sakai as well, but the exercise form, blank form that you'll need to complete this assignment is here, downloading. The example that I use, and I'll talk more about that as well, is there in case you want to know how to present your answers to your questions. I'm using Dr. Melanie Pilkington as my example here. PowerPoint slides that are attached here, and this video that you're watching now as well. On the left-hand side, you'll see your librarian and my head, and so on the top right-hand side, you'll see my name, an email that you can click, and book a consultation. As always, I'm always available to you. Email me and put Chem or Brock or your name in the subject line so it doesn't go to my junk mail. And I'd be glad to respond to you at any particular time if you need help, assistance, or you just want to learn more about chemistry and science tools as well. Booking a consultation secures in my calendar, in your calendar, 45 minutes that we can spend together to work on a particular tool. Hopefully you won't need me for this assignment, but I'm here to help you as well. Here's the exercise, 3 pages long, looks long, 10 questions. So it's 10 questions that you need to answer or provide data to. There's a number of tools here that you'll be able to use, a number of ways we explore chemistry literature as well. So hopefully, it may not be fun, but it's enjoyable, but I suggest you work at it as soon as possible, and I'll tell you why as we move forward. Here's the example that I'm going to use. I used Dr. Melanie Pilkington and filled it out so that it gives you the kind of senses how I would answer these sorts of tools and how you may want to do as well. You can't crib from this. You won't be using her examples, but you'll be using a different faculty member to complete this. So this is what it should look like when you hand it in. You can do it all at once. Take you about an hour or 2. You can do it in parts and just complete it. It may take you 3 hours or so to complete. Just put those aside, but there's important things to do to start it as soon as possible. One is to get it done. 2, in case you have any problems, but also as part of this assignment, you'll be registering for the SciFinder database, which is the main chemistry tool. Some people too often leave it to the last minute and they can't get access, or the computer setups or their defaults don't allow them to register and use it. So make sure you move forward and do this as soon as possible. So here's at the top of the assignment page. It says pick one of these chemistry faculty members that specialize in organic chemistry from the following names. These are the names that are here, including Dr. Zalesko. You find the person's name, you have to find their ORCID ID, and then I challenge you to find, if you do have an ORCID ID, to put it here. If not, to complete and fill out a free ORCID ID. You should probably do this now. It'll be advantageous to you as well. So here's the names that you could use. They're all different organic chemists. They're all renowned. Professor Hudlicki is winding his career down, but him and his son and his partner and his father are famous synthetic organic chemists. He may come to your class this term as well. Professor Dudling and Metalatos. Jeffrey Atkinson is really a neat guy. Tony, Ian, and your professor as well. You have to pick one of these particular. So I would suggest you explore what they do and how of interest they are before you start the assignment. That way you have a better sense of whether they're of interest to you and how important they would be, but they're all doable. I chose Professor Pilkington. She's in a number of areas, but an inorganic chemist that translates and transfers into interdisciplinary subjects. So does organic research and does a number of things. This is the Department of Chemistry faculty profile page, and there's one for each of your professors. Look at it and click on publications and collections to see what they do and where their research courses and research interests. You may need some of this in order to fill out some of the questions that we'll go over. And in the middle it says view website. All these professors have a website that kind of further outlines what they do and how they do it and what they publish. Here's Dr. Pilkington's group. Quite a really neat website. Their research interests, faculties, their research, their publications, a number of things, quite welcoming. On the bottom right-hand side, this is really amazing. Graduate positions available as you move through your career, whether you're a chemistry major or interdisciplinary in another area. They're always looking for researchers to do honors research, capstone projects, work in the lab, and then become a graduate student as well. Look at the invitation here. Brock is famous, as Professor Dr. Selesko says, and it's different than Americans, Brock's famous as most other Ontario universities, and Brocken specifically, of students doing lab work or bench work. It usually doesn't happen until third or fourth year, or ever at all in many American universities. But you can be involved in their research, work with them. It's a valuable experience. So on here, look at the publications guide. And here's the publications guide, or part of it. And Dr. Pilkington kind of comes here first. There's 3 submitted Impress publications on top. You can browse these, but what I really want you to do is discern how Professor Pilkington is cited and the initials that are used. So sometimes it's M. Pilkington. That's pretty specific, but in the middle there's Melanie Pilkington. So I've kind of picked it. You want to know what initials they use to differentiate themselves, because names are pretty flexible. There's common names, there's common initials. Many people have your names, and maybe you have a common name or a different name. But I looked at these publications and kind of looked at citations. And then I went to the ORCID address, which you have to clip the URL for here. So Melanie Pilkington, and she's actually completed it. If it's not live or not completed, it'll just have a name and a number. They've decided not to turn it on. But an ORCID ID is becoming famous because as you apply for grants, positions, it's becoming the default standard and the gold standard to identify a person's name, their affiliation, and this tracks all their publications and their names through their career. It's usually asked for, so having an ORCID ID is pretty proactive, and I suggest you get one as well. Interesting here that some publications are here and other things are there as well, but this is one of the questions. Grab this ORCID ID. And then, as I said, sign in, register. And this is important for people who have, let's say, Asian names or standard names like me. Ian Gordon is a pretty standard name around the world. So you may want to differentiate yourself by using your full name and initial, a full name, or 2 full names and 2 initials. It kind of helps you set you apart, and you can track that and keep that in ORCID and use that as you move forward through your scientific career. Applying for grants, funding, jobs. And you know what? Your ORCID ID should be on your resume for everything. So if someone would ask you, what is your ORCID ID? You could explain what it is. It's really an essential tool. So sign in and register, and then share what your ORCID ID is. Whether you turn it on or not, at least you have it, and you have an ORCID ID and a URL. So here's the answer to question 1 for Professor Pilkington. I put the names in, the initials, only found 2. There may be others. And she did have an ORCID ID, and I put the URL there as well. And it's Pilkington M and Pilkington Melanie. That's what I could sense. I don't know if that's all that's used, but that's important as we move forward. So pick a professor, kind of do some exploratory work, kind of see what you like, what you don't like, but make sure you validate or verify to the best of your ability their names as used in the literature, and names and initials, or initials. Because some, I know, Professor Yan, Professor Atkinson, Professor Hadlicki has a name that's almost identical to his son and his father. And I know Dr. Selesko has a number of initials and names. Not that he's given that accreditation, but other people have used that to track his publications as well. The third question, consult faculty members' research interests, publications. Choose the Web of Science database. It's a core selection of journals across all interdisciplinary subjects, including medicine. And pick 5 keywords or phrases that best describe 1, the chemistry subject areas, their topics, research. So if somebody said, what do they do? Substances, types, and classes of compounds. You now can speak the language of chemistry, and there's different words for different compounds and classes of compounds. Substances, bioorganic. You need to know that language as well. And the third one is what instrumentation, experimental equipment, as it relates to organic chemistry, do they use? It's important to know how they do their work and the skills that are important to join their lab, or to know what they do, or how they actually create the data that they use to interpret and provide research. I went through those publications, through the websites, and this is how I answered it. Using the same sorts of things, but this is what it should look like. Professor Pilkington does coordinated inorganic organometallic chemistry, molecular magnetism, and she dabbles in superconductivity, which is kind of amazing. It's kind of like physics-related research. The compounds, and heterocytic compounds, TIFs, thin films, MOFs, SIMs, lots of acronyms there, but that's how you categorize the classes of compounds that she in her lab works with. And if you went to her lab, these are the sorts of things that she'd be doing. X-ray crystallography. Crystallography is a big thing. It's a really neat thing for organic, medically applied, and bioorganic reactions in substances. X-ray, MNR, other types of spectroscopy as well. So you figure out for your researcher what sorts of equipment do they use. Pretty easy so far. Fourth one is go to the Brock Chemistry Research Guides. You've probably been here. If you're not, this will be new. And under the Articles tab, you need to register for a SciFinder account. You need to confirm by email. It does this with like 15 minutes or so, authentication, then sign into SciFinder-n. And again, many people I get at the last minute ask me, it's not working. Well, I can't do your filters or know how your setup is. And so some people do this at Brock in the IP domain, or some people do this and try to figure it out as quickly. So getting access to SciFinder-n, which you can now use, it's a free access. It's probably one of the only databases that you'll ever use at Brock that requires a separate password than your proxy Brock login, which is letters, numbers, letters, then the password that you use as well. So you need two passwords actually to get into SciFinder-n. But once you're good, you're in. You have it as long as you're here at your particular career. And then we need a screenshot of your CAS profile personal information page. That way we can validate and verify that you actually have an account, and it proves it by providing this data. So when you go to the Brock chemistry page and the library page and you click on articles, but you can click on chemicals, properties, patents, theses. SciFinder-n is the American Chemical Society research tool we pay a lot of money to get. And it's a tool that you may use in a graduate degree, another degree, or in professional practice as well. But it's a really neat tool. And I want you to begin to think and understand how it works. It's different than biology or medicine or other scientific areas or non-scientific areas you'd be comfortable with. Or free search engines like Google Scholar or Microsoft Academic. How does it work and why is it so powerful? That's part of the exercise as well. So I'm going to click on the Articles tab. And it brings up a number of articles. I put SciFinder-n in the middle, right there in the middle. There's other databases that you can use. There's more than one database, and there's probably about 10 or 12 on this particular page if you go down further. But in the SciFinder-n write-up, you can see register highlighted in the link, and that's the link you need to register for it first. So do that as soon as possible. Register, validate it, and verify it by email. And make sure you can go in, and so you can set and bookmark it on your laptop or your mobile device. Here's what it asks you to do. Your name, your number, you need to have a unique password, and there's always parameters of what your password can or can't be, but they'll help you with that. And then register. Once it's confirmed, it'll ask you to authenticate it by email within a certain number of minutes. I've already got an account, so I don't do this, but doing this as soon as possible is really important. Then you could jump back in and look at SciFinder-n. Now, when you click on SciFinder-n, whether you're on or off campus, it'll ask you to use the Brock proxy server. So you move through that portal, and then you move through the SciFinder-n portal as well. Here's the password and login. For me, yours looks no differently, but when you get in and you log in, it gives you a search engine. But on the top right-hand corner where it says account, your CAS profile, which you'll have to log into it again, helps keep track of a number of things, who you are, what you're doing. There's a number of neat tools, your default settings for SciFinder-n, but really what I need from you for this assignment is to cut and paste, take a snippet of your CS profile, which has your first and last name. This is yours and nobody else. This kind of proves to us that you didn't do this assignment with your unique SciFinder-n account and not somebody else's. So here's the answer to question number 4. I did, and it worked, and there's my name, first and last name, and a clip for that as well. Here's where we get into the meat of the exercise, question number 5. So we're almost halfway done. Go into SciFinder-n and click on References, and we'll show you how this works. Click on the Advanced Search field, and we want to search for an author's name by entering the name and initials. Remember Pilkington and Melanie and an M, so you have to kind of get a sense of what initials and first names that they use. It could be more than one. And we want to look for things for their organization, meaning Brock University. So it asks you a number of questions. You have to find a number of references. So SciFinder-n is a bibliographic database like Google Scholar or Web of Science or Scikit. You can filter it in a number of ways, and we'll go through that. There's a number of tools here I'll go over, but there's about 5 questions. You need to fill in the blanks, and then we'll show you what a completed form will be. So grabbing into SciFinder-n, here's the default search engine. So on the left-hand side, you can search by substances, reactions, and references. So those are the 3 main categories. Substances meaning small molecular chemicals and compounds. This is an organic chemistry course, so we're looking for those. Reactions are really, this is probably the only database that really does reactions. So you can find out how to make a solvent, a starting point, searching the literature by using a different tool by reactions. And it allows you to search by references as well, meaning the bibliographic databases, authors' names, titles and keywords, abstracts, words and language that can help you find. So there's more than one way to tackle this, and experts who know SciFinder-n know when to use one and when not to do another. If you look on the top right-hand side, it says draw. So not only can you look for it by substances and numbers, but you can look for it in chemical structures. And that's really, to me, that's really fascinating and unique to SciFinder-n. Learn more about SciFinder-n advanced searching. So there's neat in SciFinder-n because we've just launched it this past summer. It has a number of interactive capabilities, and you can learn more about SciFinder-n advanced search by clicking on this one as well. Here's a SciFinder-n help, and I looked up how to search for an author on the top right hand side. I didn't know how to do it, and there's a guide and an interactive video set that shows you how to do this with real life and upgraded skills. It's really amazing. So if you kind of go, how do I do this? Or I've never done this before, click on the help. It opens another window and allows you to browse and search for help screens and videos that may help you as well as you're doing your search by yourself. So let's go back to references. And so what I did was I looked under references and I put in Melanie and M, and I searched for that. And this is the search screen that I got. The answer to this set is 228 references that I've used, but every particular mode of searching in SciFinder allows you a separate, unique set of filters. See on the left-hand side, it says document type, language, and there's about 6 filters that you can use specific to references. So I wanted to find, let's say, just journal articles that were in English. It allows you to filter those as you move through your search to guide you to a more practical set. But there's 228 references for Melanie M and Melanie Pilkington. I have to decide, is that the right Melanie? Is that the right Pilkington? And how are they related to? So I searched these and I limited these by organization, Brock University. And I'll show you how that actually goes. So you can not only look at the results, you can save the results, you can save the search strategy. SciFinder-n is pretty amazing. Here's the filters we used. One was by organization, Brock University. I got 47, so only 47 of those are from Melanie Pilkington, affiliated to Brock University. I searched by document type, and one was journals, so 189 of those were journals. So you put these combinations together. And on the left-hand side for references, it shows you all the different types of ways you can filter. One of them is by database, and it's neat. SciFinder-n searches not only the chemistry literature, and that's pretty broad. It also searches the Medline database, like PubMed, for those people who are doing health sciences and medicine-related research and instruction. That's kind of neat because it searches Medline using their subjects, but then it searches the Chemical Plus, which is the chemical abstracts database, using their subjects in controlled language terms. So how do they describe a substance and how do they describe a term? So it allows you to search the two, but you can actually turn one off and turn one on as well. So in this database, we ask you to search by Brock University. And in this search, you search for journals. And it actually search, we only want to look at the CA+. Now, sometimes there's an overlap because the same records for individual publications, theses, conference presentations are in both databases, but it's a way of limiting it just to the indexing and SciFinder-n as well. So here we go. We got 44 references. So that's the answer I put into my set, and I'll show you how that works. So you can filter, but at any time you look at each one of these tests, we're looking at references mode. We got 44. We can look at all the substances dealing with these 44 records, all the reactions. All the items that cite these references as well. So it's very interactive, and sometimes it takes you down a hole. Sometimes you're following a shiny object, but you know when you're finding the right literature or not. It's a pretty interactive database. So I found a number of records. You can click on them. So I clicked on the one there. So I can save sets. So as you do your search, like most databases, you can say, I like this one, I like that one. So by the time you finish your searching, you have maybe 6 items or 20 items that you like to download, cite, or transfer or email to yourself as well. So here's that one article. Radioactivity of a whatever has the name and different authors. It tells you it's in both databases. There's 20 substances, 45 reactions, and there's a citation match, which is kind of neat. It shows you who cited this document and what documents are cited by this particular paper as well. So you need to grab this as well. So 44 is the answer. You looked at references, and I do them again. So here's where I clicked on that database I asked for, because I'm only looking for CA, and it's a fluid database. So if you clicked on CA+, the tag there, or just the text, it would actually do the limiting for you. You don't have to say click and go ahead as well. Here's the reference article that we looked at. It gives you all the information you need to know to validate and verify it. And this is what we call metadata, meaning the text that goes with it. So on the left-hand side, it tells you what journal it's in, the issue, the DOI, digital object identifiers. Almost every new peer-reviewed, scholarly peer-reviewed article has a DOI now, and that's important because it identifies that particular article. Where it comes from the databases, the affiliations, the language, these are things that we've limited by. A title, author or authors, an abstract, which is really important to describe a summary of what they did, and a sample reactions that may be important to describe this. But on the bottom it says concepts. So those are the structured language, or the terms that they've used, or keywords that they've used in chemical abstracts to describe this article, but they're interactive and they're clickable, so you can find other articles with these same sorts of concepts. Maybe there's more than one that relates to the area that you're looking in. Substances, it tells you how many there were there, and cited documents, meaning the references that are here as well. So they looked at this paper and they said, this is what it's about: abstract, reactions, keywords, kind of described it, in substances and reactions as well. So how do we cite this? But this is what you're looking for. There's a number of ways to do it, but we'll look at this because you need to cite this and put this in your paper. As you move back and you move forward, these are the number of substances in that particular paper. So they've gotten CAS registry numbers, they give a picture or a structure, and tells you how many references and reactions. So again, you can, then on the left-hand side, since we're looking at substances, see how the filters have changed to relate to substance searching or structure searching? Quite an interactive database. These are the reactions that are included in that particular paper. And again, the filters change because you're dealing at reactions, solvents, reagents. Some of the things are commons, but what it does is it describes the key or important reactions, including the substances, that relate to how you describe this paper. And they're standardized by language and by type so that they can be interactive and used in SciFinder-n as well. Kind of amazing. Here's the cited documents that are in this paper. So they're linked to SciFinder-n as well. So you can actually go to the papers that this paper is cited. And similarly, who has cited this paper since it was published, there's a way of doing that as well. So here we go. Here's that reference article. The DOI is what you need to grab. And click on full text. You can cut and paste this DOI and put it in Google. You can put the title in Google or Google Scholar. That's what I do. Or click on full text and it links to the Brock holdings. Never pay for an article at Brock. Make sure you authenticate with a Library Brock proxy. Or if you're on campus, our domain IP. That way you find things and they're free. It's strange that you even have to find anything outside of the library, or you have to pay for anything, so don't pay for anything as well. So on the right-hand side, it gives you more metadata that you need to know as well. Under the Writing Citing tab of the Library Chemistry Research Guide, this is how we kind of cite and do things that are standardized. Like AP is to psychology, or MLA is to language and literature. There's a number of style formats, and chemistry has its own. So it's a way of communicating research and talking to colleagues using the same standardized sets. Here there's a number of tools that you can use. CiteroBib is probably the best, did I say that? The best citation management tool. works better than anyone else, and I'll show you how it works, but it includes ACS style, which I'm asking you to do as well. There's other tools here, there's other quick guides, and Zotero is at the bottom. What citation style management system do you use? Do you not know what one is? Or if you don't use Zotero, what other one might be applicable? Boy, book a research consultation. People who figure out Zotero and use it with this database and other databases, note that their lives are changed. Wish I could help you. It's not part of this assignment, but Zotero is really an amazing tool to use. But Zotero Bib is great. So here's Zotero Bib, a screenshot. I put that DOI from that article because I have to cite it. It has over 10,000 styles, and I clicked on, further down the page, the American Chemical Society style, and then said click on Cite, and below it is the American Chemical Society with titles, because most chemists don't put titles in their citations. I'm asking you to do that. And there it is. So you just cut and paste that and put it into your assignment. But you know what? What's really amazing with style management, like Zotero Bib, is one, does it have the style that I want beyond the top 5? And 2, how accurate is it? Does it reflect current rules? And then what Zotero Bib does both. Both. I can't overemphasize how powerful Zotero Bib is. But cut and paste it. It looks pretty good. The italicize, the bolding, the formatting, the commas, and including the DOI. I think it's all right. So grab this. Writing and citing has other tools as well, help you to know how to write, how you to do things. And so if you click on writing and citing, there may be other tools or books or websites that I've put in here that may help you to be a better lab writer, be a better writer as well. But if you go further down on the page, it shows you other tools that you could use as well. So when you go to Omni and you click on local holdings and in SciFinder-n, it brings up this citation, which is the author, the title, some metrics here, kind of what you see in SciFinder-n. And then you click on PDF and it brings it up right here, which you can download and put to one side. Or you can put it in Zotero and they'll always have a copy of it linked to the citation itself. So there's that citation in the middle. But in the answer to question number 5, can you see how I put the numbers in? 47, 44 of them were journal articles. Here's a citation that was the most current one. I cited it using Zotero Bib. And then it asked me, is it scholarly or peer-reviewed? And I said yes, because I know it smelled, looked, and tasted like. You've probably done this before, but that's a skill you need to verify as well when your faculty member or your colleague says it has to be a scholarly peer-reviewed article. And then what's the DOI? Well, I already had it. It's in the citation. I put that in there. So that's how you answer question number 5. On that guide, it told you the ACS Guide to Scholarly Communication. This is really neat. This is the chemistry style manual. It's really a database of interactive tools. On the left-hand side, it gives you a table of contents, and it's updated continually rather than in the different editions that come out. New sections are added, new things are added. It's really an amazing tool. So if you're chemistry or you want to know how best to cite or communicate or do things like a poster or cite, or create things, this is great. On the right-hand side are the other tables of contents. It talks about journals, best practices, data in a Google era, which is kind of neat, scientific style conventions. Okay, how do you, writing a paper, do you write numbers or letters for 9? How do you call a chem? All those tools are here, but the editorial style conventions in part 5 is what we need to do. But as in the middle of this, I typed in and I typed in the word patents, because later we have to cite a patent. And it came up and it gave me this page. And if you go further down, it gave me examples of how to cite journal articles, kind of like a template. There's this example for a patent there as well. So it's really an amazing interactive tool. ACS Quick Style Guide is the default chemistry style manual. Question number 5, as I said, here's all the answers. So hopefully your answers will look something like this. The numbers won't be the same, but they'll be consistent. Question number 6, repeat SciFinder, so go back and find all the publications by that author that you've used. B in the previous question. We want to click and search by substances this time. And I'll show you how they do it. You have to find one organic, commercially available, and complex chemical compound. And I want you to name it by IUPAC nomenclature, CAS registry number, that goes in there. And if there's any more common trade names that you need to know. And then create a snippet of it and put in a screenshot of this image. So we'll go back to SciFinder-n, we'll go back to where we were, so you can complete this question like the previous one. So we got 44 citations for my author. We looked at them, and you can see the tabs at the top: substances, reactions, and citing. So those are the tools. Again, it's an interactive tool. I'm going to click on substances, and it pulled up 526 substances. Wow. So there's an answer set right there for those 44 papers. That's quite amazing. The professor in their lab may have used 1,000 chemicals, but these are the ones that are important to describe the research. But then again, it's interactive. You can actually look at the substances and the reactions and the suppliers or the references, so you can go back and forth. But here, the filters on the left-hand side say, I want to find things as a product, or you can use any other shortcut or filter to use as well. So of these 526 substances, I'm going to browse through them. I have to find something that's organic, important enough. It's not just like silica, and it's also maybe of interest to you and has enough information to do further research on it as well. So I browsed down. Compound number 41 looks interesting. I've never heard of vanillin. I hope I pronounced it right. So I chose that, and it gives you the registry number. It gives you how many references, reactions, and suppliers there are, a structure. But if you click on that number, it's a unique number to chemical abstracts services and SciFinder-n, but it's used all across the world. You can use this. Look at the one before, number 44, fullerene. It's a buckyball, which is it's amazing chemical, but I wanted to find something that's commercially available. 135 suppliers for this one and 41. Lots of reactions, lots of references, and it's organic, so I can use it as well. Pick the one that looks interesting to you. Clicked on it. This is like the homepage for that particular compound. So SciFinder and CAS, American Chemical Society, validates this, gives it a number, gives it a structure, physical properties. So it's a data database as well. So not only SciFinder-n indexes the literature, and it's a broad index of disciplinary, interdisciplinary research, but it actually provides data as well for spectral properties, theoretical properties, names, and identifiers. So it's like a home page. And you can download this, use this, or use this to jump to another place in the database as well. So you have to grab the CAS registry number, the structure, and the name as well. So here's the answer to that set. So I found 544 substances for those articles. I picked this one, IUPAC, a chemical name. Sometimes, I don't know how about you, but I can't do naming conventions, and sometimes it gets really complex, but that's the IUPAC name. There's other names that you could use, and there's the registry number, and there's the screenshot for the structural integrity of the program, of that particular compound. 7, take this CAS registry number of this compound or molecular format and go to the chemicals drugs tab in the chemical guide for the library, and go to the Pubchem database and see what you find out. So I'll do that. Here's the chemicals and drugs compounds, and there's probably 30 or 40 of them. They're most important ones. They're listed in alphabetical order. Some are truly amazing. Some are electronic, some are print, some are interactive databases. Pubchem is the National Institute of Health's. It's like Medline, and they have a whole suite of tools that are actually quite amazing. So if you go further down the page, it brings up Pubchem, and I put in the CAS number, which is unique. And it's amazing that Pubchem allows CAS registry numbers. There's just so powerful numbers and systems. And it brings up an entry. It tells you kind of like the CAS registry, the names, the numbers, and it tells you how many substances have this related compound, the literature, the patents. But if you click on the title entry at the top, it gives you a one-stop page as well. This is really amazing. It gives you the structures, it gives you the dates, it gives you the chemicals, but it's almost like a book. And here's the table of contents for structures, identifying safety, biochemical tests. NIH and Medline have done a great job, and sometimes this is even more powerful than SciFinder-n, but it gives you the sorts of things. And if you look in the middle, it tells you synonyms, but it gives you the IUPAC name as well. 7. So here's what it is. I found 1183 was the number. It's the CID or Pubchem number for this compound, just like CAS has a registry number. And here's the URL for that to find more information about it. Let's go to number 8. So we looked at references, substances. We want to look at reactions, which is unique to this particular database. We want to go in, we want to put the structure in, we want to search for it, and we want to find a patent and then cite that patent in a particular database. So let's show you how we do this. So we're going back in our search. We put in reactions, and so you can draw the reaction as a chemical structure and search for it. And we'll do that maybe some other time. But for here, if you click on draw, and you put in that CAS register number, which is unique. It pulls up an entry here. You can click on put this, the T at the top right hand puts it in the structure into the SciFinder-n software, and it's right there. So again, you can look at this and you can say, I want substitution here, not here. I want isolate. I want isomers. I want stereoisomer. I don't want. So you can allow substitution at any point. You can freeze rings, and this is where a true chemist knows it. So there's the template on the left and on the top that allows you to do these sorts of things. So you can query the database not only by substance and by name or concept, but you can do it by structure as well. So it says when you click on OK, when you have it, you can search for it there, and you can allow for substitution or not. I froze all the rings as it is here, so we're looking for this exactly in the structure. Or you can allow for substitution or partial substitution. It's quite an amazing program. It clicks it and puts it in there. So it's asking, do you want to search for this? So I don't want to edit or remove it. I want to click on the search button, and I want to search this as a reaction. But then again, I want to use a filter, and the question asks you I want to search for this and see how the filters change depending on how you're searching. We want to look at for document type patent. And we also want to look at it by document type on the left-hand side product. So we're looking for a reaction with this as a product as itself, no substitution, and we're looking for patents that relate to this as well. So 16,422 reactions have this chemical compound as a product. That's amazing. That's a lot. So take these numbers and take these citations as you move forward. 270 after I looked at products and I looked at reaction sequences just for this particular compound, and I looked at patents. And you see at the bottom, it tells you the substance role and document type. So it kind of tracks and gives you fingerprints that you can turn off and on as you move through your search strategy. So I looked at all the reactions. I found 4 in this particular patent, and I thought this would be great. And so on the left-hand side, again, always allowing you to filter by different ways. I picked up this. When you click on full text on the right-hand side, it actually says you want to check local holdings. Patents are kind of gray literature, but they're new and novel, controlled, novel ideas that are given priority rights to organizations or people, or usually labs or institutions, that they can use these things and these reactions without being stolen or taken. Not that that doesn't happen, but it gives them some protection when they move through and create new and novel ideas. So there's the reaction, there's the reagents. It tells you all the information that you need to know. But I click on ISPOSNet, and ISPOSNet is the European Patent Organization, and it has an even more impressive database. So I'm going to look up for this patent in that database. And here's the database. On the left-hand side, it gives you like a template for it. It tells you the claims. It's like a table of contents at the top, the family. So searching for patents, especially when you're doing chemistry, has this been done before? If somebody else has done this, how did they do it? Can I use these ideas? So chemistry can be very expensive, so you don't want to duplicate what somebody else has done, and you can't replicate somebody that has already had a patent for it. So you need to figure these things out before you start doing your research and actually working in a lab as well. And I clicked on the claims on the top right-hand side. It gave you 12 claims. So it was actually validated by an international organization that this patent is granted. And these are the claims, meaning what's new or novel about this particular patent that may be appropriate as well. On the bottom left, I have patent translate. Neat thing about ISPOSNet, increasingly a lot of the patents in the world are coming from Asian or non-English language, like Chinese. And so it'll actually translate the pattern and translate it in a way that you can read it and understand it as well. So we'll look at the patent, and you need to cite this patent. And just like citing articles or books, chemistry has their own way of doing this as well. So here's the answer to what I want. I got the numbers in there. I found 1,112 substances. 2,870 of them were patents for the product of this particular compound, which is amazing. Went to ISPOSNet, looked at it, kind of read what the grant was, and then I transliterated that using the ACS Chemistry Style Manual. I already shown you that. Or sometimes I just go to the internet and go patents, ACS style, examples, and then you can crib from those as well. So here's how a patent citation looks like. And this is what you need to put in the answer to this particular question number 8. Some information between 8 and 9. It says notes for writing and helping are on the writing and citing page. I kind of told so that I ask if you don't have a citation management system, why not use Zotero? We'd love to show you how to use that. The ACS Guide to Scholarly Communication, I've kind of shown you that. Section 2.5 talks about what does peer review mean, so it's a great way of looking at the literature through a chemistry lens. When done, don't forget to sign out as SciFinder-n. Remember, and don't share your login or password. The reason why there's a password is because CAS, or American Chemical Society, doesn't track you or follow you, but it triggers if indeed somebody else is using it that's not in your IP domain, or if you download too many things. So be careful, and certainly don't give it away, because people around the world covet these because it's such an expensive database to use personally or corporately or institutionally as well. There's always help. I'll talk about that. You can chat with the librarian. They can answer simple questions. Email help@cas.org. I'll tell you that on our help tab. And here's two resources to know more about SciFinder-n and training videos. They're actually great. So the last two questions are pretty easy. One is to comment one thing you've learned about the body of your faculty member's research profile through this exercise. What did you learn? Something you didn't know, or something that went, that is interesting, or I'd be wanting to know more about that. In a sentence or two, I want you to describe that. And the last question is comment one thing you've learned about SciFinder-n, chemistry databases in general, and the nature of chemical information through this exercise. Okay, I'm going to show you what I wrote down for Professor Milkington, but you'd write down some of the search things because people don't know what the correct answer. There is no one correct answer, but we really would be amazed by your feedback. So question 9, I said, Dr. Pilkington, as an inorganic chemist and her team, she doesn't work by herself. There's people that work in her lab. Conducts transdisciplinary research with biomagnetic, a wide variety of instrumentations, and really neat data visualizations, and it really concentrates on X-ray crystallography. Looks really beautiful. It's just amazing. It's like art. And it's complex at the same time. So that's what I learned about Professor Pilkington's work. One thing I learned about SciFinder-n, it allows chemists and researchers to search by chemicals, reactions, authors, substance, structures, remember that, keywords and metadata, chemistry and biomedical literature. It finds unique articles I can't find anywhere else. It tracks dissertations, PhD dissertations from around the world, and patents. Not too many databases do all three together. To stay on top of the literature, I said the art of online searching is such that every search is different. It takes patience, but it also takes practice to become a confident searcher. And sometimes new people joining research teams, whether you're a bio searcher or health searcher or psychology or whatever field you're in, sometimes you do the grunt work, and the task at hand is find research on this particular topic. So you quickly have to come up to scratch of what databases to use and how to use them and how to download and I share them and put them into citation management systems. So this is how chemists work, and you may be in a chemistry or a related field and say, oh, SciFinder may be something we should explore. Before we end, I want to look at the help page on my library guide, and there's a number of tools like A to Z Learning, Digital Scholarship Labs has workshops. Check them out. The crystallography databases, ChemDraw, but on the bottom of this page, there's a number of tools, not only my name and resources that you could use, those training videos and sites for SciFinder-n, but SciFinder-n and CAS Chemistry, not only do we subscribe to the database, we subscribe to their service as well. So they have a 1-800 number you can call, I can call, and they have an email address that you could send a message to. I often use the email message because what it does is I say, I can't do this or I can't find this. Now, it's not for your next lab, or probably not for this lab, but sometimes you just get stuck or you don't know how to do this. And they have someone with a PhD at the other end of the email or the phone, usually it's the email, which is in 24 hours, which will give you an answer. Things that I would ask them would be, I'm doing a structure search and I don't know how to do this to get these sorts of reactions or substances. Or this isn't working for me, or why can't I find this? And sometimes they'll come back and not only give you the answer, but they'll give you the strategy so that you can be better informed of how to do this. Nothing worse than being a bench chemist and going, someone must have done this before, but I can't find this in the literature. Or we want to do this using this type of solvent, and that's not there, or this type of number of steps, or we want this yield. The database can help you to do that, and if you want to learn more about it, help@cs.org is an important email address. When you email them, put in the line saying Brock University, and also put in the message that I'm a researcher. Even as a student, I'm a researcher learning or practicing with SciFinder. Can you help me with this? And just explain it to the best of your ability as well. There's always help available. Now the things that are coming up, December 8th, which is upcoming at 10 a.m., we're going to have a workshop on Reaxys, which is the European equivalent to SciFinder-n. And if you take CHEM 2P20, you'll be using this database in the winter term. So sign up for this if you'd like to learn more about it. It's a quick and dirty Reaxys, how to find relevant answers quickly. but maybe this one. Later that afternoon, I'm having another workshop on SciFinder, and I'm going to explain not only how it works, because you'll become an expert, but how is it different than SciFinder, which we used to have, and how do we transition from one to the other. SciFinder is a pretty amazing product. So join us then. Sign up for our Experience for You, and I hope to see you there as well. So there you go. Good luck on this assignment. Again, start as soon as possible. Register for SciFinder. Make sure it's working. And kind of move through this either in one shot or a number of shots. Reach out if something's not working, if I can help you, or if you want to learn more about how to use these or other tools in the library as well. So good luck on your assignment. Thanks for taking part.